content in this video is for educational purposes only. All demonstrations are intended to improve security awareness and defenses. Use this knowledge responsibly.
Hi guys, I am Cyber5 back again with another video. So I hope you all have seen the clip at the beginning of the video. So that clip is from the series Mr. Robot, in which Elliot, which was like decoding the data, his images from an audio file. He imported the audio file, then entered some credentials and all thing, and he got all the images. So that method of like hiding data inside another file is known as steganography. So today in this video I am going to teach you steganography in detail. We will be basically riding over image steganography and audio steganography. I will teach you many different ways how you can hide data, how you can extract data, types of steganography, audio, image, then inside audio, Morse code, you can say, then this call tunes, then spectrogram analysis, and inside image, LSB based, then normal, you can say Steghide, then normal using strings, cat, and all thing. So let's go. And one more, yeah, deep sound also, which is basically very easy. It's just a uh, you can say application which anyone can use. So let's start this tutorial. So first of all, I'm going to start this steganography class with this you can say strings method. Okay, so that's a, you can say, most basic one. Okay, let me go to my directory. Then stego, let's go. Yeah, let's go to this my files. Okay, so here you can say I have created some files. You can see here. So first of all, what this string commands does, strings command just list all the, you can say, readable text from an image. Okay, so this is basically used like if you can say I have an image and I opened it in text editor. Okay, like you can say this one suspicious.png. I opened this in text editor. Okay, like you can say if I cat it, you can see I will see some data. Okay, sort of, which is not readable. But if I do strings suspicious, okay, then I will see all the readable characters. Okay, then you can like to then cut it like with 8. You can say I want only strings with a length of 8 characters, or you can increase it to like 15. You will, like, if you will increase it, you will get you can say more readable strings. Okay, so this is how strings work. Okay, sometime like you can say in this image, there is an image here, you can see cover image.jpg. Okay, so if I open folder, let's open this folder. If I open this image, cover image, you can say it's normal image, nothing here. Okay, but this most simple thing which we do is like if I use this exif tool, then cover image, you can see there is some exif data like metadata of an image which you can see using exif tool. So this is also sometime used, like you can add a comment here. You can see I have added this comment. You have just nothing you have to do, you have to write exif tool, like I want to add comment 2. Okay, and then I will do equals to, then I will write this is secret information. Okay, that's it. And then I will write the image name. I think image name was cover image. Okay, and when just a second, I think instead of this, let's do, I think we can't change it. Okay, yeah, so my bad, we can't write anything. Maybe exif tool, then use cover image, and here you can say this is secret information, the comment tag has been updated. Okay, so if I want to add a new, you can say instead of comment, if I want to add something else, I think I can add a user comment, something like that, maybe, because there are fixed thing which we can add. Yeah, so after doing this I can get this somewhere, user comment maybe. Let me check. Okay, okay, let's try changing this to something else. Secret information 1 2 3 4 5 6 and random characters. Okay, now let's see what we are rating. Okay, yeah, here you can see the user comment. So this is how you can like add some random strings in it, and image will be same, but using metadata you can get that string. Okay, this is also used, but this is very common. So same what I told you, like if using string, I used string on this string cover image dot jpg, and then I will use the length limit of 15. So here you can see I will get this. This is secret information. Okay, this is secret information. You can see all the strings I got. Okay, so this is how this is the basic method, most basic method of hiding text inside an image. Okay, just write the text in the metadata. Okay, so this is very basic, nothing. Okay, then we will go to hiding a zip. Okay, hiding a zip inside this inside an image. Okay, so for that I have created a zip file. Here you can see secret.zip. Okay, and the image I will be using is, I can use anything like, okay, let's use this output.jpg. Okay, so that will be used as output. So here you can see yeah, let's use this command. This is basically very simple command. You don't have to do anything. You just have to give this right cat command, which we use to, you can say, to see the data of any file, see the content of any file. So just use cat here. Let's we do will do this cover image, then the file which you want to hide, that zip file. Okay, and then the output file. Okay, let's say I will type output 2. Okay, let's create this file. Okay, so here you can see there is an output2.jpg file, and if I open this output2, you will see it as a normal image. Okay, here you can see it's a normal image. Okay, nothing difference. But when I will do this unzip and this output2, okay, so here you can see inside this I got a secret.txt file. So that's how you hide it. I just this secret.txt file is basically inside this secret.zip, but I you can say I merged this secret.zip file with this cover image.jpg and made an image. So if user knows that this is used, like zip is inside this, they can like directly unzip the secret data. Basically this is what Elliot did with the audio file. He just inside the audio file, he you can say put in zip, and when he you can say put the secret key and all thing, he got all the images. So this is how it is done. If in the inside the secret.zip I would have, like, you can say 4 to 5 pictures, then right, I can show you. Let's do one thing, create a new folder, images. Okay, so I will just do one thing. I will put these two no, not those two. I will put these two images inside this. Move here. No, not move. Copy here. Let's copy them here. Just a second. Copy here. Okay, two images, and then I will just compress it to zip. Okay, so here you can see I have this images.zip folder. Okay, this archive. So now what I will do is I will just here, instead of this secret.zip, I will use images.zip. Okay, and I will get the output file. It will be same like previous result. We will see this output.image is same as previous. Okay, now simple thing we just have to use, we will just type unzip and this output 2. Okay, so here you can see this is telling us to replace this cover image because inside that zip there were images. So that's how you can hide a zip file inside an image. Okay, so this is also a basic method. Let's move forward. Okay, so this is the same thing, how to extract and how to do this with this command. Okay, then another thing also which I want to tell, or yeah, we can go through it. There is a tool called Binwalk. I think everyone knows about it. So it is basically a forensic tools which I can use in this image too. Like, let's use this in this output image. So here you can see it tells us there is a zip archive here. Okay, this here you can see file count 3, total size this. So I can also extract this zip file using binwalk. I will just use binwalk -e, okay, -e, and then I will type the file name output 2. So that's how you can see here extraction of zip data successful. Then there will be an extraction folder created. Here you can see when you will move inside it, you will, okay, just a second, dot extracted. So here, after when you will go inside this folder, yeah, yes, you can see these images now. Here, these are the two images. Okay, let's go back to our working directory and remove this extraction folder. Okay, just a second, let's move one more directory back and remove this extraction folder. Okay, yeah, so back again we are here. So this is how actually basically you do this hiding the zip inside an image using the cat command. Okay, now here comes the most famous tool. I think if you are doing CTF and all thing, you must know this tool that is called Steghide. So by this we can hide secret data inside an image, and also what we can do is we can put a passphrase inside it. So it actually basically uses uh, it encrypts the embedded data using algorithm like AES or DES, and here you can say it compresses the data before embedding to maximize the capacity and uses the passphrase for extraction. It's actually this Steghide does not support PNG image. It supports JPEG, BMP, WAV, and AU formats. Okay, so this is what Steghide does. It encrypts the embedded data using an algorithm. It asks for a password, of course, because it is using an encryption, and without that password, no one would be able to extract that data. Okay, so let's do this. Okay, so just I will copy this command here. Okay, and I will just paste it here. So here you can see it is asking for password. I will just put 1 2 3 4 5 6. Enter 1 2 3 4 5 6. Okay, so here output.jpg file. Yeah, I will rewrite it. So here you can see we have this output.jpg file. So let's go. Here is this output.jpg file. Normal looking, same like this cover image. Okay, 1.2 MB, and here you can see the difference between size 1.3 MB, and same here 3.6 MB because the zip file is inside it. So that's basically how you can get to know while if you are solving any CTF and all thing, if the data inside there is in data or not. Okay, so this is how you do that. So now we are here, we embedded the data secret.txt inside this cover image, and the image is output.jpg. Okay, so now what we can do is we can just use Steghide extract des sf, and we will just type this file name that was output.jpg. Okay, so it is asking for a passphrase, so I will type 1 2 3 4 5. Okay, so without the correct passphrase we would not be able to extract the data. Okay, so let's try this. Yeah, now you can see the secret.txt file. So I will type yes, and when I will type cat secret.txt, just a second. Yeah, here is this secret file. So now one more thing is here. Let's go to back to here. So here we have learned how to extract data, how to embed data using you can say Steghide. Okay, so similarly, yeah, you can use this. So I think everyone knows you can just use Steghide test as help to see all basically all the commands. This EF for embed files, then this all thing you can just read from here. Basically I'm telling the use of tools, but if you want to use them directly you can just take this help. Okay, then comes Stegseek. So what Stegseek does, Stegseek is also basically you can say a great tool. It is just based on this Steghide only. So Stegseek is basically used to you can say it just like a brute force attack, is it tries password for this, you can say this Steghide image. Okay, so here you can say Stegseek is a fast and effective tool for detecting and cracking hidden data, particularly those created by tools like ZSteg, JPHide, Outguess, or even Steghide. Its primary strength lies in its ability to perform brute force passphrase cracking using word list. Okay, so it basically use this brute force attack for that. So how it works actually? Stacks work by analyzing the JPG image, sign of embedded data, and then attempting to extract data. Yeah. So these all thing you can read it, but it's just a you can say brute force tool with brute force password. But in case of this tools like in case of steganography, like for images with embedded content but encrypted. Okay, so I will just show you how we can do this. For that we need you can say a word list that is rockq.txt. I think I am actually finding the path if the command is right. Yeah. So fd is a command by which you can use it to find any thing, any file in your system. It is very fast method. It is very effective. Here you can see I got this in few milliseconds only. Okay, so this is how you can find any file you want. Okay, so now next what I want to do is I will just use Stegseek, then image name that is output.jpg, and then this word list. Okay, so here you can see found the passphrase 123456, original file name secret.txt, extracting to output.jpg.out. So just get output.jpg.out. So here you can see we have the final message. So this is how Stegseek work. So now I think we are done with this Stegseek also. Now Stegsolve. So Stegsolve is basically a visual analyzer, okay, in which you can I will just show you, because telling it will you will not be get clear, but by seeing it you will be, you can say, get out the most. So first let's open up image file, like we will open this suspicious.png. So here you can see this is a normal image, just an image you can see here. Well, let me open a small image. Wait. I think this is not opening. Okay, no worries. Let's go to that image only. I don't know why, but that image was not opening. So let's open this suspicious PNG. Okay, so here you can see this is the image. So what actually this Stegseek does is, like, if I have written some text here which is not visible in this bit pane, so I can, like, with this arrow I can move it like different bits, like here you can see written gray bits, then random color map. Okay, so here this is how you can, like, see various bits. Then here you can see full blue, then full green, full red. So this is how you can hide data, like if I hide data in red plane or blue plane or green plane. So this is how you can see that data with your eyes. Okay, so this is what Stegsolve does. Okay, so here is same thing. Stegsolve is a powerful Java-based tool for visualizing and analyzing steganography in images. It's not for embedding, but for identifying hidden data by manipulating image planes, colors, and applying various filters. Okay, so what I told you. Okay, let's go to tool for image steganography challenges in CTF. Yeah, this is how you can install it. That you can chat GPT it. Okay, it's not too hard. Okay, then key feature you can say bit plane, which I showed you, color plane. Okay, then also, yeah, it have many features. We can combine two image, we can analyze GIF frame by frame. Yeah, these all are also very, you can say, important feature, but that you can use by your own. Okay, then next I will go to this LSB based steganography. So LSB based steganography is basically least significant bit. Okay, so this is a correct method to hide data, but it actually basically hides data in colors bit, ending bit. Okay, so like here you can see the example. There is a pixel red. Okay, the value of red is basically this, and this is 117 decimal. Okay, what would we do is using this least significant bit, that is the last bit of this uh, pixel, I will just change this last bit to 1. Okay, here you can see instead of 0 I will use 1, then instead of 1 I will use 0. So just that only, there is a very less difference. You can say this is, instead of 117 decimal it became 171. It's very less difference, and with this difference which is unnoticeable by human eye. Okay, so you can, like, basically change the pixel accordingly using the 0 1 0 in binary and all thing. And here you can see, to embed a secret message, each bit of message is sequentially inserted into LSB of selected pixel color channels. If we want to hide one and the pixel LSB 0 we can change it to 1. Yeah, that's what I told. If it's 1 we can change it to 0, if it's 0 we can change it to 1. Okay, so this is how we do. Then this is least significant bit. So yeah, I can show you the script for that. You can ChatGPT. I also created with the script with AI only. Here you can see this is a Python script which is used to, you can say, this and encrypt data inside this image. Here is the message which I want to hide, the secret message. LSB is so easy. This flag here you can see. Okay, image file is suspicious.png, and this function here you can see embed LSB. I will just open the image. Here you can see image width, image height, image size, and there are two for loop used, and the message is inserted using the bits. Okay, so this you can like study by your own. So this is how basically LSB steganography works. So if you want to like now see the data of this LSB steganography, like how we can detect if LSB steganography is there. So first of all, there are two things. Okay, if the image size is less, like this is suspicious.png, the size you can see here, size is 12.9 MB. Okay, you can see file size is 12.9 MB. So basically, if the file quality, image quality is very low, like it's getting blur and all things, then you should think of that there is steganography. Or if image size is very long, then LSB steganography is used, because like when we are changing the bit, it basically decreases the quality. If you are increasing the large, you can say, amount of data in this, it basically decreases the quality of image. Okay, so now if I want to extract this LSB data out of this suspicious.png image, I don't know why it's the size is 12.9 MB. Okay, let's see. So I will just use JSTech, which is used basically to analyze, to see if there is some hidden data or not. So here I think, yeah, here you can see I got this text LSB, so easy, this flag here. So that's how you can see if data is hidden or not. Here you can see LSB data B1R. Okay, so this is how you get to know the data inside hidden inside an image using LSB steganography. Or you can use a Python script again to do that. Okay, then to embed secret message, each bit of message is inserted into the LSB of selected pixel. For example, if you want to hide a 1, yeah, this we have done. Extraction is the reverse. Knowing which pixel and channels were used, the extractor simply reads the LSB of each channel and concatenates these bits to reconstruct the message. Yeah, so binary, here you can see the complete binary and then convert it. So here you can see LSB steganography is vulnerable to lossy compression. Okay, like as it will destroy the hidden bits. Statistically, analysis can also detect LSB changes if they alter the expected distribution of color values. Okay, so now we are done with this LSB steganography. So the extraction and you can say the inserting of data inside this image by LSB steganography. This you can basically do via Python script, and you can like embed the data and you can also extract the data. So this you can do using Python script. Then after LSB we have this Polyglot. Okay, so this is basically like it's same like the concatenation we have done in the beginning using that cat command. Like basically that's an image file, but when I use unzip, it's like unzip the file. So this is basically same. It basically work as like file formats are defined by specific byte sequence. Yeah, here you can see at the beginning like header, and sometime at the footer. Okay, so basically like in this flowchart you can see there is this JPEG plus zip polyglot. Okay, so when JPEG header, here you can see, then JPEG image data, then starts the zip header, zip data, then zip data end, and then the JPEG end. This allows basically the, you can say, the file to work as JPEG and zip both. So this is how we can do that. Like here you can see, consider a file that starts with JPG headers, then contains image data, and somewhere within its comment or application data section, the structure of zip file, okay, including everything, is embedded. The JPG parser processes its part, like because it sees the header, and the zip parser finds its magic bytes elsewhere in the file. So this is how this is done. That is the thing, polyglot. Okay. Then pixel based steganography. So these all are other you can say steganography technique. Basically LSB is the most common pixel based method, but others like color palette manipulation, then there's random pixel embedding. Here you can say instead of going sequentially, we can go to random bit by using a key or something. Okay. Then convert channels is all thing. You can study these are like there are many ways. I can't like go through all of them. Then we have this bin walk, which we have already done. Uh, it is used for forensics, reverse engineering, extracting files from firmware image. So this is what I told you. Then yeah, this all commands you can learn by your own for this bin walk. I basically just telling the tools which are used in steganography. What is steganography? Types of steganography. Like we have till now we have studied the basic CAT, then LSB, then image steganography, Steghide, and all things. Okay, so now let's go to this PNG check. Okay, PNG check is basically used to verify that file if it's corrupted or not. I will just use PNG check suspicious.png. So here you can see everything is okay. Okay, so that's how it's used, PNG check. So here you can see no error detected. PNG checks, PNG files are structured as a series of chunks, each with a specific type and data. PNG check validates this structure. If a file has unknown, invalid, or unusual chunks, it can be strong indicator of steganography or tampering. Okay. So next, let's see this SSTV. Okay, so SSTV is basically like the audio is playing and like you can get the data. Okay, so basically it stands for slow scan television. So it is a method for transmitting still images over radio. In the context of steganography and CTFs, you often encountered SSTV challenges, yeah, where an audio file is given, sounds like static or unusual. Okay, yeah, but actually encodes an image. So basically, there is an image and audio file, and when you run that audio file, it's basically sound normal, but in you can say backend, you can see it's an image. Basically, in the this here you can see encodes an image by transmitting different frequencies to represent different colors or grayscale values line by line. So instead of this same thing actually we can do same thing in that spectrogram. Okay, so like we can hide an image inside an audio file spectrogram. So this is same, but like there is a tool, this QSSTV, which is I'm not able to install in my machine, so I'm not able to try this SSTV. But when I searched for it, you can also search for that. So it's basically same thing, this slow scan television. Here you can see picture transmission method used mainly by okay radio operators to transmit and receive static picture via radio. Okay, so this is how this is used to transmit and receive static pictures via radio. Here you can see all thing, you can read if you want to. And we have this SSTV decoder also, this GitHub repo. I think just by giving this audio file we can yeah, here you can see we will give this audio file and it will result us with an image. So this is how what it is. Okay, so let's go to next. Then we have this Morse code. Okay, so Morse code basically I think everyone has done, like whenever like let me do one thing. Instead of audio decoder, okay, I'm in an audio decoder. Let's go to this home. Instead of decoder, let's encode it first. Just a second. Okay, where's the encoder? Morse. Okay, let's go here and change to encoder. I guess we will. Nope. Okay, let's search for Morse code encoder, encode and get decode Morse code translator. Here you can see. So I will just type hello. So this is the Morse code. So this is the sound. I hope you heard it. The sound of hello. So this is basically how you can say hello sound in Morse code using this dot dot space and this all thing. This is basically you can say when there was a wartime like during night. This technique is followed by you can say this light method which I showed you just here below. Basically by turning on and off the flashlight. So this is was also method was used most commonly, but nowadays everyone knows about this, so it I think it's less used and it should be less used because everyone knows about this. So there no need of this to transfer secret data using Morse code. Here you can see this. Then similar to Morse code, there is this you can say, let me show you this DTMF tones. So, okay, I think DTMF tone, DTMF generator. Yeah. Okay, so let's DTMF tone generator. Let's go to this website. I hope you are listening this. So this is how DTMF sounds like. This is basically the keypad sound which you all get. So this is also sometimes used for encrypting a number or something. Okay, there are many ways. So this also comes under steganography, DTMF tones and all things. So then there comes this spectrogram analysis, which I just told you. You can use any online tool to hide like this hide spectrogram inside an audio. Okay, spectrogram hide, you can read any video. So this is a tool. Yeah, I have used this video, so where you can just like draw things and it will just like, or you can just hide an image inside an spectrogram. So after hiding that, let me just, yeah, audio steganography, I will just download an challenge for that. If I found out the challenge, let me see what I got. Okay, so this is this Cogla. So this is basically the tool which is used to, you can say, let me see if it's downloading. Okay, yeah, I think it is downloaded. Let's see if it works. Okay, let's extract that here. Okay, Cogla. Then we have the exe file. I will launch it because I have Wine. Let's see if it works. Yeah, so it works. So like if I want to hide something, like here you can say I'm writing M J. Okay, so this I am writing, I want to hide this inside an audio. So then I will just, I think, wait, what we do, we will just render to, okay, let me see. Yeah, I think here, play, stop. Let me see, render image. Yeah, render image to sound. So I hope you are hearing this sound. So I will just save it. How to save that file? Save sound as. I have it. Uh, I think it's crashed or something. Where is that file? Here? No. Yeah, I think this Kogla.wave. So I will just open it with Audacity. Okay, let's see here. Skip. Let's close this. I hope it's same thing. Yeah. So now I will just do, I will go to here and see this is spectrogram view. So here now you can see I have this MJ here written here inside this audio file. Okay, so that's how basically we hide the spectrogram data. Okay, then I think we are done for today. I have told you, I think, every steganography technique which I hope used in CTFs, which you will encounter the most. There are many other which are used, but yeah, what came to mind, I just made a list and created this website for me for teaching you all. So this website is not hosted yet, but yeah, if you want, you can tell me. I will host and provide you the link. But yeah, I hope this much is enough for today. We have done this, basically this strings, then we have done this hiding zip inside an image, then Steghide, then Stegseek, Stegsolve, then we have done LSB based steganography using changing the bit, then this Polyglot, that is the multi-format file. Okay, then we have done this. Okay, these all things you can read by yourself. These are other method of pixel based steganography other than LSB. Okay, then I told you about Binwalk. It is basically a great tool which is used for you can say what, analyzing files, you can say, for forensics basically. Then I told you about this JSTAG. Then I told you about PNG check to validate the PNG file integrity in JSTAG. Here this is how you can extract the data. So this is all we talked about. Then I told you about SSTV. I was not able to come up with the demonstration, but because like the tool was not working in my this Linux, so I don't know how to solve that. But yeah, so I told you about SSTV. Then next is this Morse code, then spectrograms, then here comes the DTMF. So today we you can say today we have done around 15 steganography technique. So I hope this video will help you. It will increase the number of solves in steganography domain in any CTF you participate from now, maybe. Or I think you got some uh, good knowledge from this video. So that's it. Thanks for coming. Thanks for watching the video. Let's meet in a next video. Till then, bye bye.